The next rule that we're going to talk about is the quotient property. The quotient property is when you're dividing expressions, and it's what you do with the exponents when you are dividing an expression. To apply the quotient rule of exponents, one simply needs to subtract the exponents. A couple of things in this one. If the higher exponent is on top, we need to subtract the exponents to be on top at the end. And if the higher exponent is on the bottom, we will be subtracting starting with that bottom exponent. Typically, I just like to describe this as where are there more and how many more. So like for this first one, I would be thinking, okay, for the x's, there's more on the top and there's one more on the top. So the new power for x is 1. And for the y's, there's more on top, and then 5 minus 2, there are 3 more on top. So they're on top, and the y power is 3. Here, there are more x's on the bottom. And so I would take that 9 minus 4 to figure out how many more. There's 5 more on the bottom, so x to the 5 is on the bottom. And then for the y's, there's more on top. How many more? 7 minus 2 gives us 5. So we end up with y to the 5th on the top. So here's the second one. It just says, but what happens where there are numbers in the numerator and denominator of the fraction? So those are the coefficients that they're referring to, and those would just simplify like you would simplify a fraction in real life, just dividing by, dividing it down and reducing it. The quotient rule only applies to the variables that have exponents on them, so it's not about subtraction with the 25 and the 5. That part, those are the coefficients, and so that portion of it you're going to be reducing like a fraction. Here's the first example we're going to look at together. So let's look at the parts that are in this example. We do have coefficients. We have a 2 and a 6. Those are our coefficients. For our like bases, we have x's and y's. So those are the 3 parts that we're going to have to look at. Starting with the coefficients, the 2 and the 6. Thinking about this as a fraction, if you saw the fraction 2, 6, and you wanted to reduce this, they can both divide by 2, which would reduce and give you 1/3. So the coefficient part of it reduces to 1/3. Next, for the variables, I have x squared on top, and on the bottom I have x, and it doesn't have an exponent. That means it would have a power of 1. When they don't write the exponent, that's the power. So I think to myself, where are there more and how many more? There are more x's on top. How many more would be to do 2 minus 1, giving me 1. There is 1 more x on top. So the x is going to be on the top, and the power on the x is 1, because there was 1 more x on the top. For the y's, where are there more and how many more? Being that there's 5 on top, there are more on top, so the y will go on top. How many more? 5 minus 3 gives you 2. There are 2 more y's on the top. So we can simplify this. Since there is something on top other than this number 1, you don't necessarily have to write that number 1. You also don't have to write a power of 1. So we could simplify the top to say xy squared, and the bottom would be the 3. For our next example, we have a combination of a product on top. On the bottom, we have a power rule and a product. So there is a whole lot of simplifying that we're going to have to do in this problem. Let's start by simplifying the numerator. Simplifying the numerator here, I'm looking at my coefficients. The first part only has a coefficient of the 2. There is no other coefficient in the numerator, so the 2 is going to be out front. For simplifying our like bases on the top, we have x's here and here. So those are going to be multiplied together and simplified, and the only y we have is right there. So the x's, I've got x squared times x cubed remember that that is like having x to the power of 2 plus 3 because we are multiplying those together. And 2 plus 3 is going to give us 5. So that's going to be officially power of 5 on the x there. Then the y's, the only y here I have is y to the 5th. So y to the 5th is going to just stay as is. And that is the numerator simplified. Now let's look at the denominator. This part of the denominator I'm going to do first because it has parentheses in it. It has that power to power rule. Remember that power to power is to multiply. So the 2 is going to multiply with that 3 there, giving me x to the 6th. Then I need to multiply that with this portion over here, which was xy cubed. And so we're going to look at these together and we're going to see what they have, what bases they have in common. We have the x and the x here. Those are like bases. So those are going to merge together. So I have x to the power of 1 and x to the power of 6 here. So I have x to the power of 1 plus x, or times x to the 6, which means I'm going to be adding the exponents, because when you are multiplying, you add your exponents, and 1 plus 6 is going to equal 7. So the power of that will be 7. Then I have y cubed and no other y's, so y cubed will stay as is, and this is the simplified denominator. So I'm going to bring that over here. Now that I have the numerator simplified and the denominator simplified, I'm going to apply the quotient rule. Remember, the quotient rule is just when I think, where are there more and how many more? So I'm going to get my fraction bar ready. The 2 is my only coefficient, so there will be no reduction here and the 2 will stay as is. Next, I'm going to look at the x's. As far as the x's go, on top I have x to the 5th and on the bottom I have x to the 7th. So I'm thinking to myself, where are there more and how many more? Well, there are more on the bottom. 7 minus 5 is 2, so there are 2 more x's on the bottom. So the power of the x is 2. Now I'm going to look at the y's. The top is y to the 5th and the bottom is y cubed. There are more y's on the top, so the y's will stay on the top. And then 5 minus 3 is 2, so there are 2 more y's on the top. So the answer to this question will be 2y squared divided by x squared. So there's no more simplifying that can be done. For our last example in this video, we have a quotient which also involves a product in it, and then the whole quotient has this power rule that we're going to apply to it. I'm going to suggest first that we simplify the inside of the parentheses before we deal with that power rule, because there are just so many pieces inside of this parentheses that would get that power of 2 right now, and many of them have the same letters. So as we're able to simplify this together, we're going to have less pieces to distribute that power to. So the numerator cannot be simplified currently, but the denominator has some stuff going on that we can simplify. So I'm going to start by copying the numerator and my fraction bar and copying this power of 2 out here so I don't forget about any of that. And next I'm going to look at the denominator. As far as coefficients go, I only have this 3 right here. So the coefficient on the bottom is just going to be the 3, and I'm going to write that in the front. I have like bases of x's, and then I have this y here. So the coefficient is going to be written in the front, and that's the 3. The next thing I'm going to write is the common base of x. I have x to the 3rd and x squared, and we're multiplying these together, which means you're going to add your exponents. So the 3 plus the 2 is going to give me an exponent of 5. The next base I have is a y. And there was no other y's down here, so y to the 5th is just going to stay as y to the 5th. The next thing I'm going to do is I'm going to apply the quotient rule because I do have some matching pieces on top and bottom. I have x squared on the top and I have x to the 5th on the bottom, and so those can simplify. So I'm going to rewrite my parentheses and my power and my fraction bar. And I'm going to think about what's going on here. So I've got this coefficient of 3 on the bottom, and there's no other coefficient, so it's just going to stay that 3 where it's at in front on the bottom. Then I'm going to look at the x's, and I'm going to think, where are there more and how many more? There are more on the bottom, and there are 3 more on the bottom because 5 minus 2 is 3. So the x on the bottom is going to have a power of 3. Next is the y to the 5th. There's no other y's, so it's going to stay right where it is on the bottom. If everything cancels from one side of the fraction bar, what you're going to do is you're going to put a 1 there. Because we have this denominator, you have to have a numerator to have a denominator. And so as you're looking at it, what really you could think about happening is when you're reducing these x's, you reduced out 2 of them, and then that leaves a 1 on the top. Then the last thing I'm going to do is apply this power of 2. And so every piece inside of there is going to get a power of 2 applied to it. So the numerator, which is a 1, can get that power of 2, 1 squared. On the bottom, the coefficient of 3 is going to get that power of 2. The x cubed will get that power of 2. Remember, power to power is multiplying. And then the y to the 5th is also going to get that power of 2 applied to it. And now to simplify. 1 squared is 1. 3 squared is 9. For the x's, the power of 3 times the power of 2 is 6. And for the y's, the power of 5 times 2 is going to make that new power 10. And so this is the answer. And that's it for our quotient examples.